Welcome to today's presentation, Augmented Reality or AR in Heat Treatment. My name is Peter Sherwin and I am the Global Business Development Manager for Heat Treatment for Eurotherm by Schneider Electric. I want to use this presentation to outline that augmented reality is a solution used to quickly capture expertise and know-how and provide information in a format that is very comfortable to the newer, younger, digitally native worker. I've spent 30 plus years in the industry, 20 years as a heat treater in Europe and Asia, and the last 12 plus years as a technology supplier to the industry with Eurotherm. In my heat treating days, I had a passion for continuous improvement in both processing and quality. Heat treat as an operation tends to be at the end of the production process, and as such, significant time, material and other process costs have been incurred before the part sees a furnace. Any error within the heat treat operation can be very expensive. That's why we try to put our operators through ongoing training both on and off the job. With a more mobile workforce and the challenges of the current environment, we have less time and resource to help an operator come up to speed quickly. In my own experience and from 5Y analysis, 90% of issues in a heat treat shop can be attributed to operator or human error or equipment fault. And generally, time-served operators are more reliable and less error prone. If you dive into the detail, there is usually more than one contributory factor that leads up to an operator making a mistake. And it's not as simple as just training and experience. A way to examine this is with human factors engineering. This looks at the interaction between workers, equipment, and the environment. A parallel is that AR also looks at improving the way someone can easily interact with equipment and their environment. At first glance, this looks like AR should be able to help. Let's look at a heat treat example to explore this further. If we look at the table describing some key operator activities in the heat treatment of gears and compare against human factors rated high, medium and low, we know fixturing can potentially have high physical demands with racking materials, weights of parts and baskets. And we usually help with pallet and forklift trucks, scissor lifts, cranes, and potentially in the future with cobots. We keep skill demands and mental workload low by providing clear instructions. If we then look at cycle start, for a manual process, the skill demands would be high. But today in general, we have a level of automation to improve efficiency. It is normal now just to select a program and for an operator to manage several furnaces or ovens. However, mistakes in cycle selection do occur, and this tends to be due to training, poor instructions, and/or the available time. The cycle monitor is where we potentially have the highest stress on an individual. This increases if the operator has less experience because it is then more difficult to make considered judgments. One of the downsides of automation is the separation from the operator and the requirement for detailed process knowledge. Cycle issues or deviations might not be rescued, with the root cause due to lack of training, not enough available time, and/or lack of or too much process information. Okay, let's look at these categories one by one and highlight where AR can help support. So we'll go through training, instructions, time available, and process information. Starting with training. Typically, heat treat training is event-based, in the classroom or on the job. For classroom training, time is carved out from the day-to-day work, and you generally tie up an instructor and the trainee or trainees. This training is typically carried out remote from the shop floor. Studies are now showing that this type of training, unless backed up by reinforced learning, is not very effective for knowledge retention over time. On-the-job training is usually carried out during normal work activities, but you generally are tying up a supervisor or lead operator for this type of training. This training is carried out in the normal work environment with the equipment and tools to be used during normal job duties. This type of training is usually an ongoing process, so has a level of built-in reinforced learning and typically is more effective than classroom training. However, it is highly dependent on the availability and skills of the trainer, whether that's a supervisor or a lead operator. AR training is like on-the-job training, and this can be done during normal work activities and in the normal work environment. But the benefit is that this can be done without the trainer and in short bursts of time. This can be used to reinforce on-the-job and classroom training to help retain knowledge over the longer term. Next, let's focus on instructions. When a task is complex or performed infrequently, even the most experienced workers may forget the steps required or the order in which certain steps must be performed. For procedures to be effective, they must be used. There are some reasons why they may not be used. For instance, 1. The instruction, it's not readily available. 2. They are in the wrong operator language. 3. The instructions are inaccurate, and operators typically won't use if these instructions are less than 80% accurate. And 4. The instructions are out of date. From an industrial study, 90% of accidents have at least one root cause related to mistakes within procedures, and an audit showed procedure accuracy ranged from 30 to 95%. If we look at AR instructions, instructions are available. There's no hunting through filing cabinets. Instructions are readily available on the tablet or smartphone. They can be in the operator language. Many modern AR solutions incorporate translation tools. They tend to be more accurate and updated because you effectively test the instructions against a real live process every time you use them. Inaccuracies are quickly identified and can be updated, and you know that you're using the latest issue. Moving on to available time. The worst enemy for quality of performance is hurry. Tight deadlines or unrealistic metrics encourage behavior to just get it done and check the box. Shortcuts are taken and mistakes are made and not caught. Standards not followed and variation increases. Fatigue and stress levels increase and ultimately accidents can happen. So overall stress decreases the working memory capacity, and this results in distraction. Long-term memory is affected and can cause delays in action and increase in task difficulty. The quality of decision making and communication is also impaired. So if you look at communication, this is necessary to define the work to be done and how to do it. And shift handover is a key time. Communicating status of equipment, repairs that occurred, problems faced, and upcoming chores. Now the sender and receiver must both be active for communication to be effective. Both share responsibility for ensuring successful communication. It is worth noting that analysis of causes of events and poor communication identified more errors in sending than receiving. The current environment tends to push towards smaller teams, and if you add in transient workers, you ultimately end up with fewer resources with additional tasks as well as added training needs. AR can have a positive impact on available time. We've already mentioned some benefits in AR training and available accurate instructions. This all cuts down on time and resource consumed. If we also add in digitized notes, so they're available in context at the right time and location, as well as the ability to connect with experts to help support activities with remote connection into the AR view, this all aids efficient use of time and resource. The last part of this section is looking at information. Human-machine interfaces, or HMIs, are used extensively in manufacturing industries to help improve the quality, productivity, and safety of a process. However, programming errors and incorrect operator inputs have been found to account for 40% of failures of control systems. Training, software testing, and strict control of programming changes, as well as design, are all used to minimize these failures. Situational awareness concepts are used to aid an operator, and this splits into 3 different levels. Level 1 is perception. What is the current condition? Level 2 is comprehension. So what does this mean? What are the critical issues? And finally, level 3 is projection. Do I need to act now? Do I need to act soon? And what will be the likely outcome? We tend to focus on levels 1 and 2 and use a lot of operator training for 3. If we did show all the information, every HMI would be cluttered and look like this. Can you guess what it represents? This is the usual view of the car dashboard. We show only the important information that drives proper control. However, losing some context does put some pressure back on training. Moving to AR information, this is where AR really stands out. We can still have the real-world view of the process, for instance a heat treat furnace, but now we can overlay information to help the operator understand what is going on. So we identify alerts in context and aid level 2 comprehension. We know the data as well as the importance. To help with level 3 projection, we can add instructions in the form of procedures or workflow that act as troubleshooting guides overlaid on a real view of the situation. As described, many benefits exist with today's practical use of AR technology. The technology has developed so that it is very easy to create AR applications in a few days rather than weeks of programming. Okay, let's take a few minutes to see how a practical application for a vacuum furnace is created and used. These technical sessions are aimed to be 100% educational, but in order to demonstrate general functions of AR, I do need to show a quick view of the software. Please see this as one solution of a number available on the market today. AR products do range in complexity, from simple image recognition through to systems allowing manipulation of complex 3D images within your space. Note the video in the background is now running at 3 times normal speed to avoid too much time in the builder process. We first start by setting up language options. In this case, we're going to add Spanish to the main US English language. We then create our vacuum furnace area and we will use image recognition for the vacuum furnace. In step 3, we are adding the vacuum furnace image to recognize. Step 4 starts adding the elements we want to see on overlay on our normal view. We start adding text and then more detailed information in a list, such as some detailed documents. We can also add links to external applications. Other elements are available to use, including real-time variables, but in this case we will just add a subscene illustrating a vacuum hot zone. Finally, in step 5, we will set up a very simple workflow for completing a temperature uniformity survey. You just need to add more steps and decision boxes for more complex operations. Once the project elements are complete, we just run the software to build the application, and then we can transfer to the tablet. Now we have the video back at normal speed, let's do a quick setup with this new project, and then we will see what an operator would see through the tablet. First, let's create a new card that links to the FNA 2020 project. We can then log in and access the scene we want to view. Unfortunately, I don't have a vacuum furnace in my basement, so I will rely on this picture of one on my wall for the application to recognize. You see, it doesn't recognize the other images because they are not set up in this particular scene. Next, let's freeze frame the view so we can more comfortably look at the elements. The subscene gives a view of the hot zone. Now let's have a look at the documents we set up. I can adjust the view of the documents on the screen so I can still see the vacuum furnace along with detailed information. Next, we will use the link to the external application. In this case, we are just referencing a web page. Returning to the AR application, we open the procedures and show the instructions on the screen. The cost of this technology is also in the reach of all manufacturing industries. rather than historically being solely used in richer industries such as oil and gas. Instructions, procedures, and workflows can be tuned to exactly the needs of your particular situation rather than having to rely on generic solutions. Let's look at some next steps to consider. In the current environment, we know that many businesses are focused on cash flow and costs. Restarting furnaces to meet demand and controlling costs by focusing on critical maintenance and optimizing spend around regulatory compliance. Following this business recovery stage, we think that most plants will start to look at transformation, gaining efficiency and flexibility through digital solutions. This is where AR can aid. We already mentioned that smaller teams and transient workers are becoming the new normal. So we must figure out how to do more with less. Leveraging connected workers using AR tools and other digital solutions, along with evolving process mastery, will be an important focus. Finally, we believe that to future-proof your organization, there needs to be a drive to flexible connected plants. This will involve building in greater resilience to potential risks, including pandemics, cyber attacks, and supply chain vulnerabilities. This will involve planning and quick action to enable risk mitigation, the use of smart supply chains, and leveraging digital to its fullest extent to achieve self-organizing production. To find out more about how AR can help you achieve efficiency and flexibility, please visit the Eurotherm by Schneider Electric virtual booth at Furnaces North America 2020, or alternatively email me peter.sherwin@se.com. Thank you for listening.